Arduino group of microcontrollers are being used in numerous applications. They are low cost and I had the opportunity to use Arduino Nano and Arduino Uno. We will start off with Arduino Nano. It was released in 2008 and has 30 male I/O headers with DIP30-like configuration. Arduino Nano can be programmed using Arduino software. It can be powered through a Type B mini USB cable or from a 9-volt battery. The operating voltage is 5 volts and input voltage can vary from 7 to 12 volts as per the Arduino website. It has a flash memory of 32 KB and a clock speed of 16 MHz. It can communicate with a computer, another Arduino and other microcontrollers. There are 8 analog in pins and 22 digital I/O pins. It weighs only 7 grams and has a size of 18 into 45 millimeters. Arduino Nano has been used in amateur radio transceivers in addition to numerous other applications. Arduino Nano is an open source hardware. I have been hearing of Arduino Nano for the past couple of years as the microcontroller in the popular QRP radio micro BITX. I thought of buying one. This is how I received it. They say that it is a breadboard friendly version. You can see that it can be fixed on the breadboard. The pins, 30 pin dual inline package that can be fixed on the breadboard. That is why they say it is breadboard friendly package. Then there is a socket here. This is the programming cable which I got along with it. You can see that one end, this is a USB Type A plug. The other end is Type B USB mini. This is not commonly seen with many of the devices now. Earlier I think I have seen it with some mobile phone chargers. And this will go into this socket for USB Type B mini. This close-up picture shows the 32-pin 80 mega 328 microcontroller CPU that runs with a 16 MHz oscillator and has 32 KB flash memory. Reset switch is seen beyond the label Nano. Here is a better view of the reset button. PL3500 series CMOS reduced voltage regulator chip can be seen here. A tantalum capacitor labeled 476A can be noted in this picture. This is just an attempt to learn as much as possible about the structure of Arduino Nano before proceeding further. If anyone of you can add more information on the component seen, that will be very informative. Bootloader is also known as boot manager and bootstrap loader. Bootloader is a small program responsible for booting a computer. In case of Arduino microcontroller, bootloader is a small piece of software which allows uploading of sketches into the Arduino board. It is pre-programmed on the microcontrollers on Arduino boards. If it has been corrupted, it can be restored by a process called burning, flashing, or programming a new bootloader onto the board. According to the manufacturer's website, easiest way to burn the bootloader to classic boards, which include Uno, Mega and Nano, is using a second Arduino board as a programmer. 6 male-to-male jumper wires are used to connect the digital and power pins of one board to the corresponding pins of the second board. The programmer board is connected to the computer and burning is done using the Arduino Integrated Development Environment IDE, which should be already installed on the computer. Fixed Two Arduino Nano microcontrollers on a solderless breadboard and connected the USB Type A to USB Type B mini to one of them. Board connected to the computer using USB cable will be the programmer board and the other one the target board. Then I connected the 5-volt pins of both boards together using a red jumper wire. They are labeled as such on the devices. Next, the ground pins of both devices were connected together using black jumper wires. When I connected the Type A USB pin of the power cable to a power bank as a trial, power and L LEDs of both boards lit up. Of these, the L LEDs were blinking slowly as usual. Pin between 5-volt and ground is the reset pin. Pin 10, D10 of the programmer board was connected to the reset pin of the target board using a white jumper wire. Then pin 11, D11 of both boards were connected together using a blue jumper wire. That is the controller out peripheral in, COPI, and it is the pin that the Arduino uses to send data to a peripheral device. Next, pin 12, D12 of both boards were connected using a green jumper wire. It is controller in peripheral out, CIPO, the pin that transmits data from a peripheral device to the Arduino controller. This was followed by interconnecting pin 13, D13 of both devices with grey jumper wire. That is the serial clock SCK pin used to synchronize data transmission between the Arduino and the peripheral device. Once the boards are connected together, we can proceed with burning the bootloader in Arduino IDE. Programmer board was connected to the laptop with Arduino IDE software installed. Power LED is lit and the L LED is blinking slowly. Now the programmer board and target boards are ready for burning or flashing the bootloader in the target Arduino Nano board. As a preliminary evaluation for planning Arduino control projects, I thought of looking at the output voltages and currents available from Arduino Nano. Digital output pins of Arduino Nano provide 5-volt output in high state and 0-volt in the low state. You may remember my old post in which I used an example sketch to make the built-in blinking LED on the Arduino Nano to blink at varying speeds. The LED will light up in the high state and go off in the low state. Maximum output current mentioned is 40 milliamperes, but it will be safer to use only 20 milliampere to avoid damage to the ATmega328 chip inside the Arduino Nano. Hence, if you are connecting an external LED to the Arduino output pin, use a current limiting resistor. Otherwise, excess current draw can damage the chip and or the LED. LEDs do not need 5-volt to glow, though there is some difference between different colors of LEDs. 5-volt pin on the Arduino Nano board can provide up to 500 milliamperes. But this is the combined power supply for the board itself and other low power components. Total current draw of all Arduino I/O pins combined is 200 milliamperes. I am checking the outputs from my Arduino Nano board. The board has been powered using a power bank. This is the power bank which I am using. And then I will check the pins. This wire here is the jumper wire is connected to this 3.3 volt pin, and this black wire is connected to the ground pin. You can see the ground pin here through the breadboard. Now we will see what the voltage is. I have connected both to the multimeter using crocodile clips. Meanwhile, the power bank has gone auto power off. I will switch it on. Now the power bank has been switched on. You can see the light blinking on the power bank, and with the power bank switched on, the output at the 3.3 volt terminal is 3.31. That's acceptable. I have connected to the 5 volt pin. You can see 5 volt pin, and LEDs are blinking very weakly. That is because the power bank has gone for auto power off. We'll switch on. Now it is on, and you can see that the output measured from the 5 volt pin is 5.02 volt. So that's also acceptable. Now here you can see two LEDs. One is power LED, which is continuously lit, and there is a L LED which is blinking. That blinking speed can be adjusted using the Arduino sketch. Again, auto power off of the power bank. Now I have connected to pin number 13. This is pin number 13, and the other is to ground. You can see the LED is blinking, and when the LED is blinking, the output voltages, you can see maximum it goes up to 5. That is when the LED is on. In the on state it goes nearly to 4.9 something, and when LED is off, you can see that it goes down to nearly 0. Now I have connected a blue LED to the D13 output pin using a 330 ohms, again power bank auto timeout. Connected a blue LED to the output pin D13 using a 330 ohms resistor. You can see the resistor here. This is a 330 ohm resistor. Now the external LED is blinking along with the internal built-in LED. That's because according to the blinking time, it will provide an output at the digital pin 13. Now I am measuring the output, the current. I have set it in the 20 milliampere range in this multimeter. It is 20 milliampere range, and you can see that when the LED is lit, it goes up to 5.4 milliamperes, and when it is off, it comes down. Because it is a rather rapid change every second, it is difficult to measure the exact value. Again, there was again auto power off. Almost 5.5 milliamperes of current is shown here. Instead of the 330 ohms resistor, I have switched over to 220 ohm resistor. You can see that the current drawn is a little more, nearly 6.8. That is the current drawn. That is because the resistor in series is of a lower value, 220 ohms. So this is a safe value because the recommended is below 20 milliamperes. Now this is drawing only 6.8 or rather 7 milliamperes. That's safe for the Arduino board. This is a relay module meant to be used with Arduino Nano and other similar microcontrollers. You can see the input pins here. These are the input pins, Vin, ground and VCC. The pins can be seen better now. These are the 3 pins. I'll use these jumper wires. You can see that one end is a socket and the other end is a pin. I'll use these to connect the relay. You can see that the sockets have been connected to the terminals on the relay. They are the input terminals, and this is the other end which you can connect to a breadboard. Now you can see the connections. That is D13. Is that D13? that is the digital output from Arduino Nano, has been connected to the input, and the black terminal, the central one, has been connected to the ground of the Arduino. This is the ground, and the white one, which is the VCC, input to the relay to run the circuit of the relay, that has been connected to the 5 volt. This is a 5 volt terminal from Arduino Nano. Arduino Nano can give a 5 volt input to devices connected to the board. That is, a maximum of output is possible is only 500 milliamperes. But of the 500 milliampere consumption of the Arduino board, 200 milliamperes will be used by the board itself. Maybe another 300 milliamperes is available for this relay. Usually relays take only about 70 milliamperes. So let us see. Now I have connected the power supply, that is a power bank, to the Arduino Nano. This is the power bank, and you can see, observe what is happening. The red LED on the relay is the power LED, which lights up continuously, showing that the relay module is energized. The green LED shows that relay is being switched. So the relay is being switched on and off intermittently. I am using a blinking LED sketch in the Arduino Nano. Usually it blinks for 1 second on and 1 second off. That is the principle of digital output. That is, on is 1 and off is 0. This is the digital pin 13, which is used for blinking LED. I have shown it earlier. And this green LED is the relay indicator, relay state indicator. When the relay is on, it lights up. That is because Arduino gives a 5 volt output in the digital pin in the on stage and 0 output in the off stage. This LED is being lit from a different input, that is the direct 5 volt input from Arduino. That is not being switched. That's why it is continuously on. I have edited the blinking LED sketch in Arduino Nano. That is an example sketch which is free, public domain sketch. Usually it has 1000 milliseconds on and 1000 milliseconds off. I have edited it and uploaded again so that it will be 5000 milliseconds on and 5000 milliseconds off. That's for easy recognition of on-off. Otherwise, this LED will be blinking very fast, once a second. And according to the blinking of that LED, you can know that switching occurs in this other side also. These are the other ports which can be used to control other devices. I have a motor here, water pump, which can be controlled. Anything can be switched on and off by that circuit. You can see 3 terminals here. The central terminal will be common, and one of the other 2 terminals will be either normally on or normally off position. That we will try out in another experiment. This is a 21 watt 12 volt bulb. It's actually an automobile bulb. It's an enlarged view, 4x view. Actual view will be lesser. I wanted to show you the ratings. This is the actual view. I have soldered wires to both terminals because I don't have a holder at the moment. Holder is usually in the automobile. This is a demo testing this bulb with a 12 volt battery, storage battery. I am testing the current drainage by that bulb, that is 1.54 amperes. This is the bulb, and you can see that multimeter is in the 10 ampere range. I have connected the bulb through the always on port. Central one is common, and this central one, that is common, and this is always on. The common port has been connected to the battery, and through the multimeter I am going to connect the battery. I have connected the battery, and the bulb is light, and we are reading 1.56 ampere. This is the 10 ampere port. So the current drawn from the battery is 1.56 ampere through the relay. So this is because the relay is in the always on position. Now I'll see what happens when the Arduino port is connected. Now I have connected through the Arduino. This is the Arduino, and this has been powered, and you can see that now the Arduino is switching the relay. You can see that now it is drawing 1.57 amperes, and now it is off. When the green LED lights up, the bulb is off. That is for 5 seconds. When the green LED goes off, the bulb is on. So it is the other way around. That is because of the connection in the relay. If I connect to the other terminal, the reverse will occur. So it depends on what you want to do. So I am driving the 12 volt 1.5 ampere circuit using the Arduino Nano. The program in the Arduino Nano keeps the bulb on for 5 seconds and then off for 5 seconds. The program can be changed by editing in the Arduino IDE software. I am checking the current drain in the digital pin of the Arduino Nano. Now it is 0 because the Arduino is in a switched off state, and now it is 3.5. So you can see that maximum current drawn from the Arduino pin, that is this pin, that is the digital pin, D13 pin, is only 3.5 milliampere. You can see that the range selected is in milliampere. I'll change it to 20 milliampere, so it will be more accurate. It is 0 when the output is off. When the output is off, the light will be on. That is the reverse connection. You can see that the light will be. So maximum current drawn from Arduino in the D13 pin is only 3.5 milliamperes. At the same time, we have seen that the current drawn by the bulb, this is the automotive bulb, is 1.5 ampere at 12 volt. This is a 12 volt battery. So we are using Arduino Nano to switch a higher voltage, higher amperage, 1.5 ampere 12 volt circuit using just 3.5 milliamperes from the D13 pin of the Arduino. This is the principle of this module, relay module. Relay module has an input of 5 volt at 3.5 milliamperes only. So that will not strain the circuits of the Arduino. This is the Arduino Uno board along with the connectors. Pins are there here, and this is a USB type B socket. This is a power jack. End-on view of USB type B socket and the power jack over here. This is USB type B pin along with the USB socket, and the other end of the USB cable is type A pin. You can see the difference between type B plug and type A plug. Now you can see the number in the Atmel Mega 328P microcontroller. Without shining the spotlight over there, it is very difficult to see. The microcontroller is quite small. This is a magnified view, and now you can clearly read the inscription. This is LM358. Now I have powered the Arduino Uno from a power bank, you can see here, using a USB type A to type B cable. And as in case of Arduino Nano, you can see that one LED is continuously lit while another LED is continuously blinking. Then there are other LEDs. Now it has switched off because power bank has auto switch off function. Now you can see that the power bank is not active. If you want, you can push here and then activate it, and the LEDs will start blinking. Then there are other LEDs seen here. You can see RX XT, that should be equivalent to TX. And this is the on indicator, it is written as on, and this LED is marked as L, that will be corresponding to the L LED in Arduino Nano. There are other devices here. One is this looks like a crystal, and this also looks like a crystal. Then there are chips here. Those I'll take photographs, enlarge, and then show you. This is to get an overall idea of what is there in Arduino Uno. This is the reset button beside the type B socket, and this is the power socket, which I have not used. So overall idea you can get about Arduino Uno from this video. We will have more details later. Let us have a look at the chips and some other components seen on the Arduino Uno board. This is the ATmega 328 on the Arduino Uno board, about which I had posted earlier in connection with Arduino Nano and as a separate post. It is an 8-bit microcontroller which has 32 KB flash memory. ATmega 328 has a maximum CPU speed of 20 MHz. The components marked 47 and 25V are surface mount capacitors of 47 microfarad capacity and working voltage 25 volts. LM358 is a low power dual operational amplifier integrated circuit. As you can see, it is an 8-pin integrated circuit. The part labeled 662K is a low dropout LDO regulator for providing a stable voltage supply. It is rated for 3.3 volt 250 milliamperes. MS1117 5.0 is a linear voltage regulator with low voltage drop. It can provide 5 volts regulated output with an unregulated 9 volt input. CH340C is a USB to serial converter chip. It is a full-speed USB 2.0 device with baud rate 50 bps to 2 Mbps. Below that you can see a crystal oscillator, the inscription on which is not clear, though I tried visualization from various angles with different illuminations. The reset button near the USB Type B port is seen here. A1SHB is a P-channel MOSFET. This is the underside of Arduino Uno board with no chips seen. Another crystal oscillator with the part number clearly seen, unlike the previous one on which the number was not clear. This view shows both the crystal oscillators together. LEDs in a vertical row can be seen marked as ON, RX, XT and L. ON will light up with power on, RX and XT during data transmission, and L blinks while power is on, and the blinking rate can be controlled by programming as with Arduino Nano. On and L LEDs have been captured in on position after connecting a USB power bank using a Type A to Type B USB cable. Arduino Uno, you can see the Uno designation here. Board has been connected to the laptop using USB Type B cable. This is Type B end, and that goes to the laptop with a Type A connector. What goes into the laptop is a Type A connector. What goes into the Arduino Uno is a Type B plug, like the usual printer cable. That's what is here. Arduino Uno also has a power supply option of direct power jack here, but I am not using it. You can see that an LED is blinking now, and another power LED is continuously lit. That is power LED. This is LED L.